Hey folks, welcome back for the last time to Networks and Cybersecurity. Today we're going to learn the very last thing we're going to learn how to set up HTTPS on our web server. This is a very useful thing to do. One of the first things that you should do before you deploy any web service, as I've described earlier, is to get HTTPS set up. But boy, what a pain it is. And today we're going to experience the pain of setting it up. It's actually not that bad on IIS, and it's not that bad on most platforms. The hardest part is getting a certificate, and that's been vastly simplified over the years. The biggest pain these days is remembering to renew your certificate, because although Let's Encrypt is free, these certificates are fairly short duration, which means that you either have to set up some kind of script to do it, or if you're a paranoid like me, do it manually because you don't want the script to fail and your web service to stop working. At a certain point, you need to let go of that paranoia and just let it happen automatically, because there's no way you're going to update all of your different SSL certificates. But I digress. Many people still do it manually. Many organizations will have somebody or a small group of people whose job it is to keep the SSL certs up to date, rather than having it done automatically. They'll have like an email or something sent to them automatically to remind them to do it. So there's still a lot of human error on that end, but I think probably the majority of organizations just have it happen automatically somehow now. Now, if you pay for your SSL certificate, you can have it expire over a much longer interval. So something like, seen like a year, maybe even more. So why do we have to do this? Well, I've got Wireshark open on my home machine here. I'm going to visit my website. That's everybody's favorite website, jager.crabdance.com. And it tells me this is a web page. Let's see what happened in Wireshark. Nothing. That's weird. Did I get the IP address wrong? Oh no, it's cached still. Ugh, okay, let me open it up in another browser. I'll just get that in Edge or something where it's not cached. Jager.crabdance.com. Okay. Caching makes live demonstrations in class more difficult than it has to be, doesn't it? Alright, let's see what happened. So, first of all, traffic's all nice and green. That means unencrypted in Wireshark. We see a plain TCP session starts. We see a SYN, a SYN-ACK, and then an ACK as we expect. I don't know why we have an extra SYN at the beginning here. That might be from a different session earlier, but we've got our SYN, our SYN-ACK, and our ACK. Then we start getting our HTTP messages over the application layer. We've got a GET for crabdance.com, keep alive, insecure requests. Look at my user agent for what Edge calls itself. I told you that these were funny looking, so here's an example of a user agent for a real browser. Mozilla 5.0, Windows NT 10.0, Win64, x64, Apple WebKit, KHTML, like Gecko, Chrome, Safari, Edge. These are what they often look like. They'll have the names of many different browsers in there, plus browsers you probably don't recognize or long dead ones like Gecko. It basically comes from a long-standing war of browsers trying to masquerade as one another. But anyway, we've got our user agent and what kind of files we accept. We accept text, application, image, etc., etc. Let's look at what the response looks like. Here is probably the biggest problem, is that the website, all of its content comes in the clear. So if this was somehow private, if you visiting that website might be embarrassing, if this is your bank account details or whatever. Yes, we can also encrypt the contents as we have done before, but that is a difficult thing to do correctly. The best thing to do, best practices, is to make sure that the whole communication channel is encrypted. And even if you were able to successfully encrypt the payloads along the way, observers in the middle would still be able to see what a person visited, what kind of pages they looked at once they were there. That kind of information can be important to hackers and evil nation states alike. As, for example, if you visit howtobeadissident.org and click on sign up, that's entirely different than if you click on send hate mail, for example. The state would be very interested which button you clicked on howtobeadissident.org. But aside from that silly example, there are a lot of situations where you don't want everyone to see your browsing. So we've pretty much switched as a whole on the internet to HTTPS everywhere, and the vast majority of websites are HTTPS supporting and slowly getting to the point where they are HTTPS exclusive, so you must have HTTPS to visit them. There's a GET request here for the favicon, which I think is interesting to point out too. A properly compliant web page should have a little icon up there, right? It should have a little doodad demonstrating what my web page is all about. Let's look at workspaces, for example. It's got nothing. Okay, so that was a bad example. But anyway, lots of websites will have a little icon up there, a custom icon. You probably recognize the popular ones like Reddit and whatnot, but I didn't specify one, so what do we get? We get a 404 not found when we make that request for the favicon, so the resource you're looking for might have been removed. And I also want to point out, look at how verbose the response is. Look at how much stuff is in there. You've got not just a 404 not found, but also all of this text, HTTP and HTTPS, which runs obviously underneath it is a very wasteful protocol in terms of how much stuff it sends. So it sends that 404 not found basically as a whole page of its own. And in fact, the not found page is actually larger than my website right now, because my website is just like 6 lines and it's tiny. And then look at what happens after it's done transmitting my website. Because this connection is not persistent, as soon as it's finished downloading the contents of the website to my host here, my host terminates the connection. It sends a fin, and this TCP session is closed, so it is not kept open. So that's a non-persistent connection, and this is relatively common on the web too, that you'll see the resources get requested and then closed. So how does that work for more interactive websites? Places where there's stuff playing, information's constantly updating, or getting messages. Well, those guys have to keep refreshing their information for you, and they might take advantage of some sort of persistent connection, or they might have a script running in the background aside from the HTTP that handles passing that information along. So many different approaches there. Okay, so let's get this secure to the point that we actually can see nothing rather than the plain contents of the web page. So you know a page is running on plain HTTP if it has HTTP obviously in its prefix, but modern web browsers have gotten rid of that to save space. These days you look over to the left of the URL for the not secure indicator. If you click it, it'll tell you your connection to this site is not secure. Don't enter any sensitive information on the site, for example, passwords or credit cards. Obviously, credit card numbers, another reason why we really want HTTPS. So hopefully everybody's gotten their workspace fired up by now. First, we're going to make a separate web page for our HTTPS content, because I want you guys to be able to use what you've made already for your homework or any other needs you may have for it up till the end of the semester here. So let's make a separate web page that supports HTTPS. And IIS supports the ability for you to have as many web pages as you'd like on one server, which is very nice if you're the owner of many domains. All you have to do is make a separate folder inside of www.root for every domain you plan to have. So if I own jaeger.crabdance, maybe I own jaeger.kittendance, maybe I own jaeger.dogdance.org, I can host all of those on the same server. This is probably assuming that none of those are very high traffic, and of course they're not, but I can host all those in the same place. So I'm going to host the HTTPS version of jaeger.crabdance as its own website for just the ability to keep everything I've done so far separate. Alright, so create a new folder, right-click, go to New Folder. You will be asked for admin rights. I named mine HTTPS Testy. You can name yours whatever you want. Just remember what you called it. The name's not important. So I just called mine HTTPS Testy here. Next step is going to be for us to get into our IIS control panel. So go to the Windows menu, hit the Windows key, or however you want to get there. And then you're going to find the IIS configuration panel. Mine is already in my recents, as it probably is in yours, but if it isn't, then you can type IIS and that'll bring up the IIS manager. So click on that to open it. Okay, there's only one server in this IIS group, and that's our Amazon server that we're on. So click on your Amazon server on the left there, and you should get to this page here. And on this page, you are looking for something called server certificates. For me, it's in the middle here under IIS. And the reason that we need to make a certificate first before we can proceed to getting our real certificate is because of just a quirk in Windows where it asks you for a certificate when you make an HTTPS web page. It won't let you proceed to the next window unless you have one. So I just make a temporary junk one for testing, and then I go back and I pop in the real one when I'm finished. There is a workaround to this, but it's even more clunky in my opinion, so this is my standard. You let me know in either chat if you have a better process for this. But we go to server certificates, and I've already made my junk certificate here. But you're going to make one, I'll make one with you here. So we're going to create what's called a self-signed certificate. That means that we have no authority backing our certificate. It doesn't go to any of the certificate authorities. We are the ones that sign it and say that it's legit. And that, of course, doesn't go very far in terms of trust. However, self-signed certificates can be really useful in organizations too. You can have somebody make a self-signed certificate, make it expire whenever you'd like, and then just install it on other machines that you want to trust that certificate. So you can install that self-signed certificate on any other machine. After making it here, I could copy it over to my desktop and install it on my machine, and then my machine would trust this junk certificate that I made. So I'm going to create self-signed certificate on the right here. I'm going to specify a name for it. I'll call this another junk cert. And we can call this web hosting cert. We'll call it a web hosting cert. Personal will go to a different location on the disk, and I think IIS defaults to looking in the web hosting folder, so that's where we're going to want it, so we don't have to navigate through directories to find it. So make sure you put it in the web hosting store, and that's it. It's just going to make that for you. So you're going to see a couple pieces of information here. First, you've got the certificate's name, who it's issued to. This is the name of the server here. Alright, and then we've got the issued by. Note the expiration date. So I just made this. Today is the 11th. It expires on the 10th of next year. So the self-signed certificates have an expiration date of a year. This one that I made a while ago, you can see I made it about the 29th or so, and it expires on the 28th. So the self-signed ones by default will last 1 year. And I'm going to do a poll to see if everybody's gotten this far. Let me know if you had any issues getting to this point. And disregard this certificate. This is the one that we are actually trying to make. So this one's going to be later. Alright, I'm just going to minimize this window for now. Actually, no, we have to continue on in IIS Manager, sorry. So we're going to go to Sites now. So there's a folder, if you expand the drop-down here, called Sites. You don't want to expand it further, we just want Sites here. And we're going to click on Add Website on the right, or we can right-click anywhere in the blank area and go to Add Website. Either of those is fine. So we're going to go to Add Website. You can name it whatever you'd like. I named mine HTTPS testy again, but it does not have to match the name of the folder. I just did that because I wanted to. And then for the physical path, we're going to find that folder that we made earlier. So for me, it's www.root HTTPS testy. And this is the step where it's a little bit hacky. You could proceed from here with it as HTTP and then go back and change it to HTTPS once you get your certificate. My preferred method is to set it to HTTPS here, and then you're going to have to pick that junk certificate that you just made. Otherwise, it won't let you proceed. So you can leave all of this default, all IP addresses, port 443 is fine. And then for the host name, you're going to enter your DNS name for your website that you got the other day. So mine would be jager.crabdance.com. Okay, so that would be your host name. And then I'm going to pick the junk certificate that I made. Normally I would click OK here, but I've already done this, so I'm going to leave this screen open for a second. Again, name it whatever you'd like. Make sure the physical path goes to that HTTPS folder you made in www-root. These you can leave default, so IP address, all unassigned, port 443. Make sure the host name is the DNS name that you got earlier, so mine's jager.crabdance.com, and pick your junk SSL certificate, and then you can hit OK. Now you're going to need something inside of that folder for us to access. You can either copy your existing index into there, or maybe make a little bit of change to it so you can tell that it's different. I just added the words, this is a secure HTTPS web page to mine, otherwise it's the same index.html file. You don't need this ASP.NET client, but Windows makes it for you automatically, so just leave it there. And the index.html file has to be in there. So put a index.html file inside of HTTPS testy at this point. While you're doing that, I'm going to go back and change my certificate to the temporary one, that junk one, so we can see what that looks like. So I have changed it to junk cert. Okay, and now I'm going to visit HTTPS from my home computer again. HTTPS jager.crabdance.com. And we get this message. Oh no, my connection is not private. Attackers might be trying to steal my information. Why is that? It's because my certificate is junk. Nobody signed off on it. Nobody trusts this, let alone the Chrome web browser, or Vivaldi actually web browser. Of course it doesn't trust the certificate. Now you can continue to the web page anyway, even if there's a bad certificate, by clicking on Advanced and then going to Proceed here, and that'll take me to my web page. This is a secure HTTPS web page. Let's examine the certificate here. It says your connection to this site is not secure, certificate invalid. If you click on, let me go back and do that slower. If you click on the word certificate with invalid next to it there, it'll bring up the certificate in Windows, and we can see that this CA root certificate is not trusted. You can install it if you want it to be trusted. It was issued to this Amazon server by itself, and it was issued 11/29/20 through 11/28. This is my old junk certificate from the 28th. We can see that it's hashed with SHA-256. We can see it uses a 2048-bit RSA key as its public key, just like we used in the previous homework assignment to encrypt our passwords. And we can see that the certificate path is just itself, because it's self-signed itself. Okay, so that's not good. We want a certificate that browsers will actually trust. Someone asked, what did we use to make our site? Well, assuming that you visited it in the browser in Workspaces, hopefully it's still in your history here, and you can find it there. If not, it might be in your history on your home computer if you accessed it that way. And if not, we used FreeDNS to register it, which is afraid.org, freedns.afraid.org. You should be able to see your domains under subdomains after you've logged in. So freedns.afraid.org is where we registered it, if you don't remember the name. Alright, now we're going to make a real certificate using Let's Encrypt. Now there are many different services out there to access Let's Encrypt certificate signing authority. We're going to use one called WinAcme. I'm going to go back here to show you what the Google search looks like. WinAcme is one of many such clients for Windows. I find it to be pretty straightforward. Let's call it even idiot-proof. It's about as easy as you can get as far as command line things go. I don't know of a good graphical interface-based one, but this is about as easy as it can be. Don't forget to visit HTTPS // your web page to get the HTTPS pop-up. If you just visited your web page as you have in the past, you wouldn't get the HTTPS pop-up. So make sure you visit HTTPS / your page. And also make sure that it says started here in the IIS manager. It's possible that you forgot to check the box that said start immediately. So everything should look like this. It also might not appear if you spelled the DNS wrong. So if you spelled the name of your website wrong in the binding when you were doing it, it also might not appear there. So to change that, you right-click on it, go to Bindings, click on your site, go to Edit, and there you can change the host name if you made a typo. If yours says stopped for your HTTPS one, you want to right-click on it and go to Manage Website and go to Start. This shouldn't conflict. You should be able to have both the default and the new one running at the same time because they run, one's on HTTP, one's on HTTPS, so it doesn't consider them conflicting. If you maybe made one of the settings incorrectly, if you didn't pick HTTPS, then it will say either yours can't be started or something similar to that, like the error that we see in Discord. That's probably because when you were making the website, you didn't pick HTTPS here, you picked HTTP. So go ahead, the easiest way at this point is probably just to delete the one you made and follow the steps again. Make sure this time you pick HTTPS as your binding. Make sure the host name is your DNS that you got earlier, and make sure that the physical path is different from your default web page, which just uses the www-root folder. You're going to want to use www-root and then the folder that you have inside of it, that HTTPS testy folder, as your physical path. And then again, you got to pick your junk certificate. Not sure about the access denied error. You can show me a picture of that one. That one I've not seen before. Access denied might be you don't have admin rights to edit these websites. That would be strange. Well, let's see how many people got this. Let's see. Got to their website over HTTPS and saw the bad cert. Forbidden is probably you are trying to go to the PHP folder, which doesn't exist in your HTTPS version. So if you put your index file in there, the other thing is you might have not put an index file in there. So make sure that you have at least something in there that we can see. So just copy and paste your existing index.html into that HTTPS testy folder, or make a new index.html. You need to have a file in there. You might have to specify jaeger.crapdance.com/index.html in your browser too, I think, depending on the browser. That might be an issue. I don't think any browser will be confused by that. Most browsers will fetch index.html directly. Make sure you're not trying to access your domain /php/index.html, because that might have been in your search bar already. Make sure you're just heading to your domain /index.html. And make sure that there's an index file both in your regular www root for your default web page, and also one inside of your HTTPS testy folder, or whatever you called it, for the web page that you'll see when you're connected by HTTPS. In the meantime, how's everybody doing finding WinAcme? The first two links to the GitHub are fine. If you want to compile it from source, you can download it there too. I go to their website, winacme.com. It's actually the third result for me when I look up WinAcme. So that's WIN space Acme, ACME. I do not remember what it stands for. But that is, Acme is the generic name for clients that sign you up for certificates, basically. So I think it's named after the protocol that's used to fetch certificates or something like that. Once you're at this page, this WinAcme page here, you're just going to click download. It's going to download a zip folder for you. Lovely zip folder. If you navigate to your downloads folder or get to it from your browser, you'll find the WinAcme zip folder in there. It's WinAcme v 1.13.978 is the newest. You can see I did this earlier too, so I have a couple versions. Win 2.1.13.978 is the newest. Since that's a zip folder, you're going to right click on that guy and you're going to go to extract all. You can just use the default. We'll just leave it in our downloads folder, no big deal. So everybody should have looked up WinAcme. Click that third link to get to WinAcme's website. Click that download button. Downloads WinAcme. You're going to right click on that and go to show in folder, or navigate to your downloads folder another way. And then you're going to right click on it and go to extract all and extract those contents to the download folder, or wherever you would like to have them. Obviously, if you were actually going to use this later, you'd probably want to hang on to them and not just extract them into your downloads folder, which is going to get recycled in a bit anyway. Alright, then we're going to go to PHP myadmin. Sorry, not PHP my. We're going to go to that WinAcme folder that we just extracted. And we have this WACS application. That's the WinAcme application itself. We're going to have to run that as administrator in order to have access to IIS's directory of websites. So right click on your WACS and go to run as administrator. You're going to get the old security pop-up. Say yep, and it's going to launch. There you go. So this is a command line application, which means you're going to have to do a little bit of typing. Now we're going to want to create a new certificate here. So you're going to type an N and press enter. It's going to ask you which of the websites in IIS should be scanned for host names. So I only have one website on IIS that has host names. The default one doesn't count. And its number here is DOS2. So I'm going to hit 2 and hit enter. Now you might have a different number than 2. You might have a 3 or a 4. You also might have different websites if you made different websites earlier. So pick the one that you're going to be doing the HTTPS for. So the one that we just made. Okay, and then it's going to ask you which of the bindings you would like to bind to your new certificate. So basically, what domain do you want this new certificate for at this point? So previously we were choosing which of IIS's different hosting, let's call them threads or applications, we're going to be looking for sites on, and now we found all the sites that are being hosted on that binding. Now we want to know which of the domain names being bound here do we want to get an SSL certificate for. So again, mine's the only one here, the first one. For me it's number 1, and I'm going to just pick 1 and hit enter. At this point, you've done everything you need to do. It's going to ask you, do you want to continue with this selection? And you are going to hit yes, or type Y, and then press enter again, because there is no hitting yes. So you're going to type Y, hit enter, and it's going to make your new SSL certificate for you. And I'm going to close out of it because I've already made mine. I don't want to renew. So you would hit yes. And then I'm going to run through this one more time, just in case anyone missed it. So again, right-click Run as Admin. If you don't run as admin, you won't see any of your websites in IIS. You're going to go to N for New, Certificates. You're going to pick the website that you would like. So HTTPS testy for me here is number 2. Then pick the domain that you'd like. So jagercrabdance.com for me is 1. So 1, and then I'm going to say yes and hit enter. Whoops. Well, I'm just going to hit no at this point. Okay. But you're going to hit yes all the way through. Yeah, anything it asks you to do at that point, you can hit yes. And then once it's finished doing what it's doing, it'll take you back to the very first screen where you get to say new again, and at that point you are all set. Now, if you did this correctly, it's going to automatically have updated your certificate in IIS. If not, you have to go back to the IIS manager here, or even if it did, you can just verify that. Go back to the IIS manager, right-click on your website and go to Bindings. Click on the only thing there and go to Edit, and then make sure that the SSL certificate selected now is the one that starts with IIS, and then it's got the name of your website and then the domain. It's much more fancy looking than the junk cert that you had earlier. That is the one that Let's Encrypt just generated for you through that WinAcme. So make sure that that's the one that's selected, and then hit OK. It should already be selected just after finishing with WinAcme there. Okay, so now I'm going to go back to my website. Note I still have my little insecure lock there. I'm going to refresh, and lo and behold, the lock has turned solid. My connection is now secure and trustworthy, and HTTPS works, and everything is wonderful. So let's see, I have a valid certificate now. Let's examine some of the details of my valid certificate. This was issued by R3 because very recently Let's Encrypt started working with R3 as their root issuer. If we look at the certification path, it was issued by R3 and then signed by DST root California X3 as its top level root. Let's see if I go to their root certificate. It's good until 9/30/2021. Awesome for them. Let's see how long mine is good for. Mine is good until valid from today to 3/11/2021. So that gives me, I think, 3 months exactly. So that's the default for Let's Encrypt certificates. You get 3 months exactly of HTTPS-ness. And that's about it. We got HTTPS now, so we're secured. Everything else is pretty much the same. You'll notice the public key is even more secure. It's 3072 bits, so even exceeding that standard. We've got a couple bits of information here. The DNS name is jager.crabdance.com. Yeah, nothing particularly interesting that we haven't already looked at. So, alright, that's how you get your HTTPS setup. Now let's look at what that appears like in Wireshark. Hopefully this website isn't cached. It is. Okay. I'm going to close out of it. Start over. And open it in Edge. Alright, so a lot more traffic this time from getting it in Edge. If yours, the lock hasn't changed to secure, try opening it in another browser. Yours still might be cached, or just wait a minute or two, or close the page and reopen the tab. Sometimes that does it too. Uh, and then make sure that in bindings your certificate is the correct one. Let's look at all the stuff that happens now. First, we still get the beginning TCP handshake because every TLS session still starts with a TCP session being established. So we get that SYNAC handshake. Then we get all of those different messages we learned about when we were looking at how TLS works. So there's a client hello, there's a server hello. The server hello sends the certificate as well. Remember I told you these often get bundled into the same message. So here you see in Wireshark the server hello, certificate, certificate status, server key exchange, and server hello done, all bundled into the same message. Let's see if we can find the certificate here. Yep, there's the old certificate. I'm going to just look at its contents as bytes here. In Wireshark, you'll notice, come on, highlight it for me. There we go. You'll notice jager.crabdance.com in there because that's part of my certificate, right? So see that certificate's being transmitted in the clear. You'll also notice let's encrypt in there because they're the ones that sign the certificate, right? So we've got a couple pieces of info that we saw back in the certificate message before there. And then we've got our certificate status message and all the other stuff that we looked at with HTTPS. Wonderful. And that's basically it. So you can look through all of this and you will not see any information about the website anywhere in it. You will not see the this is a secure website or any of the index.html file contained in there because all of that info is encrypted. From that point on, nobody can snoop what we are doing without defeating our HTTPS security. So awesome. Any questions? I guess an obvious one might be, how do we then use this in Java? How do we go ahead and use the HTTPS variant instead? Because all of our Java URLs and everything for the PHP scripts and whatnot, we were using HTTP. So will all of that stuff fail if we migrate the whole website over to HTTPS? Yes, they will. And the answer is simply to add an S, pretty much. The conversion from the HTTP version to the HTTPS version of using all those PHP scripts with the URLs and everything in Java, basically all we've got to do is add an S to the end of everywhere where we had HTTP. There are a couple more settings that might need to be changed. We might need to specify which TLS versions and ciphers to use if we're strictly, being as best practices as possible. But besides that, basically just changing those HTTPs to HTTPSs will allow us to do everything we were doing before with the added security of HTTPS. And that allows us to send stuff to the database and from the database without worrying about people in the middle intercepting it, because those messages are easy to read in Wireshark. Those post messages are easy to read in Wireshark. Remember, we saw that last time. Okay, so that's it for all the cool stuff that I can show you on the CSVM. Sorry we didn't get more time with this lovely thing. Definitely could have done a lot more cool things with it. The final will involve it. I'll post the final later today. Those of you who still haven't filled out the course evaluations, please do so. There's some extra credit available for doing it. I'll probably live stream me reading those out just for giggles, so look out for that sometime during the break. I think they go out to me like the week after finals week or something, so keep your eyes open. It'll be a good time. I will read all your hate mail live. And if you have any other specific comments about the class or anything, please let me know. We have a couple minutes left, so let me just cover a couple of the other topics that we didn't quite get to that got pushed aside because we actually got access to the VM unexpectedly. And those are a couple things that you should keep in mind for your application development in the future. So we looked at loads, balancing, aliasing, we looked at how DNS servers worked, we looked at the global DNS network and everything. Alright, let's look at a couple of application layer protocols and some of the stuff that we can learn from them. I forgot to hit shift. Okay, so first let's look at FTP. Give us 100 on final, I give good review. Well, you're not going to know what you got on the final until you submitted the evaluation, right? So I'm not as interested in the stuff at the top of the evaluation that everybody does, but my evaluation has some specific questions that I added that I'm interested in, especially what you thought about the technology that we used. So that's your opportunity to tell GCU what you thought of their wonderful CSVM. At the point the evaluations went live, these workspaces weren't a thing yet, so if you still haven't filled yours out, you can talk about these, say which one you preferred more, all that stuff. Did you like Discord, YouTube, all those different delivery mechanisms? Because we do have one more semester online, most likely, or at least my classes do. So I would like to see what you enjoyed tech-wise, what you didn't enjoy, and then what topics you liked covering here, what you didn't like covering here, all that kind of stuff. And I always read my evaluations, every single one of them. You'll watch me read them live in a week and a half or so if you have nothing better to do. FTP was designed for transmitting files from A to B, which is still a remarkably hard problem in 2020. If I have a 50 megabyte file and I want to send it to my friend, boy is it a pain to do so, right? You can upload it to ZippyShare, assuming you both have AdBlock. That's pretty much still the best way to do it. It has been for something like a decade, which is sad. Mega is also pretty good if one of you have an account, but there really is no great way to just send your buddy a 50 megabyte file. Most folks upload it to their Google Drive or something and generate a link and turn on sharing, but that's really kind of a tedious process for something that should be so simple. FTP was used to transmit files to and from some server that you're administering or interacting with. So typically you'd connect to a server with SSH and move files to and from it with FTP. So what I want to point out here is that FTP uses two channels. It runs over two different TCP ports. It has two different connections active at any time. One is for commands and one is for the data itself. So whenever you're designing an application that has this kind of structure, maybe you have a login, maybe you have commands that need to be sent back and forth like FTP does. Put those on a separate stream from the data that's coming through if you also have a lot of data that's coming through, and that way your data coming through never throttles your commands, and it's much easier to view a Wireshark trace of all your commands, and all kinds of different advantages from doing it this way. So if you have the option, this is often the way to go. The problem is that synchronization becomes pretty difficult at that point. So FTP is considered out of band. When a protocol is out of band, that means that the control signals come in a separate channel than the data signals. So far, everything else we've looked at, like HTTP, all of those have been in band. Any kind of controls like gets and posts and requests, those come on the same connection as the data actually coming through. So if you don't have any expectation of things happening in a particular order, or at least less of an expectation of things happening in a particular order, go for out-of-band instead and make yourself a separate control channel. If you want to give FTP a shot, FileZilla remains probably the most common one to this day, despite being something like 20 years old at this point. Then, of course, if you're a Linux user, all one of you, then actually none of you, but I wanted to say one, then you have FTP built directly in there. You can start your own FTP server too. IIS has the option to start an FTP server in addition to the servers that we've done so far. So if you want to give that a shot, go ahead and go into your workspaces and start an FTP server. Give it a try there. There's a few commands listed too if you're interested. And then how about email? So email's a weird one. To many people's annoyance, especially developers. The email protocols that are in use today come from like the 70s, maybe even earlier, and the most common one is still SMTP, Simple Mail Transfer Protocol, which is positively ancient. Now, email doesn't work by sending emails from you to your recipient. Email is a algorithm that uses an intermediary, and this is what makes email interesting, is that we have mail servers that handle the actual sending and receiving of the mail, so users never actually send mail to each other. Instead, every user has a mail server, and they have a mailbox at that server, and the server sends and receives mail for you on your behalf, very much like the postal service. When you send a letter, you don't walk it over to anybody, I imagine. Servers typically try a few times to deliver your mail if it fails. And then on the receiving end for the client, we have user agents or mail readers. Those are the client side that actually retrieves the mail from the server, so it gets your mail out of the box and shows it to you. And they also handle the passing of your outgoing mail to the server. So you've got your two parts. You've got your mail servers that actually talk to one another and handle the sending and receiving. And then you've got your user agent or your mail reader, which handles passing the mail and the commands to and from the mail server. So SMTP comes out in the early 80s, used for communication between the mail servers, not between the user agents and the servers, but between different servers themselves. This is why it's still around after all this time, because the level of security required is substantially lower, because these messages only travel between mail servers anyway. It actually only supports the transmission of 7-bit ASCII, which means that if you want to send an image or something, you have to go through the trouble of converting it to 7-bit ASCII. So most email clients even today still use SMTP. That is, whenever you make an attachment to them, they convert your attachment to 7-bit ASCII and send that. A huge pain from a development point of view. Mail servers will queue outgoing messages, and then they transfer them by TCP, basically. Here's what a sample SMTP message looks like. You put the domain, there's a hello, then they respond with their domain and a hello, and then there's the mail from line, sender okay, then there's the received from line, okay, recipient okay, and then some data, that's the body of the email, then we end it with a period, etc. Very tedious. So let's look at a couple of the commands we saw there. We saw hello, mail from, receipt to. This is the main problem with SMTP, and this is why you get spam all the time that tells you that they are from your bank or from Netflix or from PayPal or whatever. SMTP, when you send somebody an email, going back to this, you specify this receipt to field and it just takes your word for it. Okay, there's no verification that you actually own the web server that they're claiming that the email came from, or that the email actually originated from there. So it's very easy to spoof that an email actually came from somebody else when you are sending it. Now, modern web servers, modern email servers have a lot of different mechanisms for dealing with spoofed emails like this, but as everybody who has an email knows, a lot of these slip through the cracks, and you end up getting emails that look like they're from PayPal or whoever when they really aren't. Although if you examine the received from field on most of those these days, you'll find that it's actually not PayPal.com anymore. So that particular attack is a lot less popular. You've got your multi-purpose email headers, which are probably outside the scope of the limited time we have left there. And then for accessing your mailbox, you might have heard of POP3 and IMAP. If you've ever had to configure accessing your mailbox through an app on your phone or on your computer, you'll be familiar with these as some of the most common user agents for accessing and controlling your email. So these are a couple of the more common ones for accessing your mail server. Alright, I think that's all the time we've got, so just a little bit of extra info for you in case you ever design your applications in the future. Thanks for tuning in, everybody. I hope you had a good semester. I'll upload the final later tonight, and good luck on it. Have a good winter break, and see some of you next semester.